Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to this tutorial video. We are group 5, consisting of myself, Ida Mulyani, and my colleague Ahmad Zulfadli from the Master Program in System Engineering, Gajah University. In this video, we will demonstrate how to use LEAP, the Long Range Energy Alternative Planning System. We will guide you step by step starting from registration, downloading, and installing the software up to using it to build an energy model. LEAP is powerful modeling tool developed by the Stockholm Environment Institute, or SEI. It's widely used across the world for energy policy analysis, long-term energy planning, and greenhouse gas emission assessment. With LEAP, we can simulate how energy demand and supply evolve over time and explore different policy scenarios. For example, how to transitioning from the fossil fuels to renewable energy can help reduce carbon emission. Now, Let's begin by learning how to register and get access to LEAP. To begin, open your web browser and go to the official LEAP website at leap.sei.org. This is the official platform developed by the Stockholm Environment Institute. Before we can download or request license, we need to create a user account. Click on license, click sign up as a new member. Fill in your personal information carefully. Your full name, your institutional email address, your organization or university, occupation, and interaction for joining. Well, for example, uh, to use LEAP for academic research and energy system analysis as part of my master's study at Gajah University. After completing the form, click submit. You will receive a confirmation email from LEAP. Make sure to check your inbox and also your spam folder. Open the email and click the activation link to verify your account. Once your account is active, log in into the LEAP website using your registered email and password. Okay. After login, open the license menu and select menu license and select request academic license. In the license, request form, fill out the following details. Mention that your intended use is for academic or research purpose. And then state that you're a master student in system engineering at Gajah University. Optionally, you can include your supervisor name or your thesis topic. Click submit, apply no, and your application will be reviewed by the LEAP team. And then within a few business days, you will receive an email from the Stockholm Environment Institute containing your license file and activation instruction. Make sure to download the file and safely store the license file on your computer. Next, let's downloading the LEAP application. From the main page, click on the download tab and then choose the latest version of LEAP that match your Windows operating system. Click download LEAP installer and wait until the download is complete. Once finished, locate the installer file, usually named LEAP setup in your download folder. And then now let's install LEAP. Double click the LEAP setup file to start the installation. And then when prompted by window, click yes. Click yes to allow the application to make changes to your device. Follow the installation step. Click next to continue. Click I accept to term in the license agreement. Next, choose the default installation directory, then click install. Wait for a few minutes until the installation process is complete. Finally, click finish to complete the setup. After installation, open the LEAP for the first time. You You will be asked to active your license. Click Active License, then locate the license file you received via email, select the file and click Open. If successfully, a message will appear saying LIP is now licensed for academic use. Congratulations, LIP is now fully installed and active on your computer. In this tutorial, we have demonstrated how to register on the LIP website, request an academic license, download, install, and activate the software. For the next section, the tutorial on how to use LIP for energy modeling will be presented by my colleague. Thank you.
Hello, in this video, I will get you through the process of developing for the low carbon model for Mamminasata metropolitan area, which is our project for the subject on renewable energy defined in MeTSi. So for our thesis, actually, KSN Mamminasata, you can Google it. So it was a metropolitan area consisting of city of Makassar, Regency of Maros, Goa, and Pakala. It was the largest urban cluster in Eastern Indonesia. This model will be developed using a platform or LEAP, which is a software from SRE, Platform Initiate Environment Institute. The goal of this project is to explore how to transport, how the traffic electrification and integrated mass transit system can leverage the greenhouse definition. So the basic of the project will based on the Nasional by Ahmad, Latif Energy Networks in 2024. The development is in combination of lead and wood with self simulation software for water resources. Okay, but in this section, in our political doesn't use it just use it. Before starting the model, there is a research preparation and for defining the model bundles, like checking the base and collecting all the relevant data. So in our project, we need to collect all the data. We collect the structure also in the database. So what is the assumption of the other system that we need to include? The model itself will have the zero participation and collection between the two. Okay, this is the I don't know my statistics for that. So some data in this model will be using the statistic of electricity 2023 from PLN, plus angka from the Ministry of Energy General, juga also statistical data from BPS Indonesia, and power plant statistik UPTL 2025 dan 2025 is related, and also IPCC 2006. Okay. Now, once we are ready to build the model, so first we need to set new project like SN method. Okay. The first thing you have to create the settings. And these there are three tabs that you have to focus on, like electric activity, we will organize the information for energy generation, because it was not a national scope, before it was national. And other things is the energy effort, the energy effort actually we don't really simulate that. The land use of a person because of focus or handle data. The vessel is 2020, suppose scenario will be 21, the annual is 2050, monetary years, it's will be following, the 2020, the position is 2050. The other tab is building as default. The way to create the model is first you make sure to add the assumption, like in my Excel, I have three variables of the assumption, that's population, then the domestic revenue to diambil, and the capital of each before each person. So also I also get the projection data, the projection how many population growth in Mamminasata from 2022 to 2050. Okay, so 2022. So like you and the assumption we look at and then enter population. So we can use the assumption uh, in this verse it equals 1 million, so it equals 1 million, and then You can see that the number for the base is 2.87. 2.87. So it is the current scenario. The current account will be the base, and then we will develop the scenario. Then after we predict the assumption, we will go into the demand. In our demand, we uh, divided the expectation into three branches. So you can see the category the technology is medium sensitive. The category is like a group of type of application that we're going to use. In this model, we will first make it into private sectors. It was non-public application. Then others like we like the on the demand and add public application. Okay. And also the right, which is supply chain system. It was mainly to transport goods, not people. In which you will detail the branch and so what type of transportation use, what type of technology like cars, gasoline cars, so the technology energy intensity, public application, if you use gas, like this, and then you will need to complete all the technology into the system. Next, we will type into the transformation. So first, we need to get the module because it was this project, then analyze the effect of transportation into the lot of electricity that needs, and from that we will conclude how much the carbon will be produced. So it was not really simple non-structured model because we need to create the process. We will need to input the capacity of each generation and also the cost. Okay, and the efficiency will be able to efficiency, not losses. From this electricity generation, you will add the process. So in some our KSN, there are few electricity generation model. There are coal, this one like in the PLTU, or wind power, like in the Kawasan and Bagu, that out of the Management region. The feedstock will be coal, and this one will be using the coal bituminous. Then also gas power. Actually the same with the coal one. Where gas is burned to produce heat to turn the turbine on PLTU or wind power generator. So this one is using natural gas and etc. Like you will need to compute all like hydro, diesel, solar, and wind. Just to be clear, you are also entering like the other modes of transportation that in our district not exist, like in this analysis, like electric bus. So because one also we always showing how that an integrated mass transportation, electric bus is will be introduced in the later date in our scenario. So you still have to enter the variable. So you can see at this activity level, you can see the number of the carbon dioxide. We will add that also in the increment of physical decreasing or increase by using the formula in this tab. Now we will get this scenario. We can select this scenario. So we are creating three branch of scenario. The first one is GAU, business as usual. As usual. Then, so there are two types. Like if you are selecting this and click add, you will get a new branch from the current account. This is select this type of calculation. This one is scenario for when the government forcing the policy to move into electric vehicle. The last one for this is the classification. In this scenario, the government, this is the sample of when you are selecting one scenario and you click add, you will get a branch of those scenario. Okay, close. Now you can see the drop down, the scenario. So like in time account, electric bus is 100. When you are into electric generation, it will be changed. The couple that you can use like import. So it was the calculation now. Like instant, and then you get the final result. I'm sorry. After 2020, like in 5 years, how much it will change in 2022, like you can enter the projection of progress. You can also just use like the formula like flow and of step. In this, we are using interpolation. Interpolation will get that not that small, but the progress is can be seen like each year. It will be generating a number for each year. Like this is 200, then 2025, 200, 300, and then 250, and then 400, and then 500. So just sorry, so you have to check the value that you enter. This was the error. Okay. So now we will see the complete structure of our model. After you complete all the data, so yeah, after we complete all our structure of data. Then we can create the calculation and analysis. That will be into calculated. Okay, for the some error, we have to actually find the potential because mainly we are using calculation for in some years it will be some more than 100% like this like this. So I think the volume is more. Okay, then after that we can select like demand from each of scenarios. And calculation. I think that's all from me. The user, the model open right now, and you're gonna see some chart of the model data, and you can modify like what is the output and what kind of data you want to use to present. I guess I will go for now. Thank you.